Well, we just stated that the fundamental theorem of algebra would indicate if we've got an exponent, the leading term to the highest degree, the leading term being the one that's got the exponent to the highest degree, that we would have that number of roots within the complex number system. Now, they could be real numbers or they could be imaginary numbers. And if they're imaginary numbers, they're going to come in pairs. So we're going to work through a few polynomial equations to determine the number and the type of roots. And we'll have to use some of our factoring skills in order to do this. So we start off with x cubed plus 2x equals 0. All right, well, so right away I can see that I could factor out an x, my greatest common factor, and then I would end up with x squared plus 2 equal 0. And now we're going to set each factor equal to 0. So x is equal to 0. Well, there's one of our roots, and it's a real number. And then over here, I got x plus 2 equals 0. So let's solve this one. So then if I subtract 2 from both sides, then I got x squared equals negative 2. And taking the square root of both sides, well, if I took the square root of both sides, let me do it like that, then I've got x equals plus or minus the square root of negative 2. Well, the square root of negative 2 is the same as, I'm going to do it like this, I guess. I got room over here. That's equal to plus or minus the square root of negative 1 times the square root of 2, right? And what's the square root of negative 1? I. So then we can say that x is equal to plus or minus, imaginary numbers are going to come in pair, I times the square root of 2. So our zeros that we have then are 0, we got positive I, square root of 2, negative I, square root of 2, and let's see the type of roots. Well, we got 1 real and 2 imaginary. Well, I'm so excited about that, I just want to do another one. Are you ready? Are you ready? Okay, x to the 4th minus 16. Well, when I think about that, I see 16. The square root of 16 is 4. Square root of x to the 4th would be x squared. So I really have a difference of squares, don't I? Which we know should factor this way. X squared minus 4. X squared plus 4. And that equals 0. So we factored the difference of squares. Now let's take each factor and set it equal to 0. So I got x squared minus 4 equals 0. And I got x squared plus 4 equals 0. Let's over here on the left, let's add 4 to both sides. So I got x squared equals 4. And then let's take the square root of both sides. So we got x squared equals plus or minus the square root of 4. So that x is equal to plus or minus square root of 4 is 2, correct? I think so. Now let's take that second factor and let's set it equal to 0. So I got x squared plus 4 equals 0. Subtract 4 from both sides. We got x squared equals negative 4. Let's take the square root of both sides, plus or minus. So the square root of x squared is equal to plus or minus the square root of negative 4. But the square root of negative 4 is the same as plus or minus the square root of negative 1 times the square root of 4. And what's the square root of negative 1? That's I. So x is equal to, and what's the square root of 4? 2. So it's plus or minus 2i. How about that? So what are our zeros? Well, I've got negative 2. I got positive 2. I've got negative 2i. And I got positive, I don't have to write the plus, positive 2i. There's my 4 zeros. I was x to the 4th. I got 4 zeros. And real, imaginary, well, I got 2 real and 2 imaginary. Well, I'm still having fun. I think I'll do another one. Uh-oh, maybe I don't want to do that one. All right, x cubed plus 4x squared minus 7x minus 10. Thinking about grouping that, but I don't think that's going to work. Well, let's see. What are the possible numbers of real zeros that we could have? Remember, it's plus or minus it's all the factors of the constant over all the factors of the lead coefficient. My lead coefficient is 1, so that doesn't complicate things. So let's see. I could have -1. Let me write it like this. Plus or minus 1. I can have plus or minus 2. I might have plus or minus 5. And I might have plus or minus 10. Now, I could try synthetic substitution under the factor theorem. And if I synthetically divide by one of these, and if that factor, if my remainder, equals 0, then that is in fact a factor or a 0. So let's see here. What can we do? I don't know. Just for fun, I'm going to check -5. I'm going to put -5 in the box. I'm going to write my coefficients 1, 4, -7, 10. I'm going to draw a line, bring down the 1. -5 times 1 is -5. 4 -5 is -1. -5 times -1 is +5. -7 plus 5 is -2. And that should be -10 right there. Sorry about that. There's my negative. And -5 times -2 is +10, and -10 is 0. So, actually, I could say that x minus -5 is a factor, which of course that becomes x plus 5. Now, I've got a depressed polynomial here, and that would be x squared minus x minus 2. And let's see if we could factor that. I'm going to draw 2 sets of parentheses. I got an x and an x. My constant is a negative. My middle term's a negative. I know I got to have a plus and a minus inside the parentheses. The factors of 2 are 2 and 1. So I think if we got x plus 1, x minus 2, yeah, if I FOIL that back, it's going to be x squared minus x minus 2. Now let's set each of those factors equal to 0. Well, let's just set all 5 of them. So I got x plus 5. That comes from my synthetic substitution. So x is equal to -5. I got x plus 1 equals 0. Subtract 1 from both sides. X equals -1. And I've got x minus 2. Set that equal to 0. Add 2 to both sides, and x is equal to 2. And so my roots are, I got 3. Everything's looking good. -5, -1, +2. Real or imaginary? Well, they're all 3 real. Now, you might say, Mr. Williams, we've had enough. Let's quit. I'm going to say tough luck. We're keeping on going. I got to do one more. All right, now I got 3x cubed minus x squared plus 9x minus 3. Let's see. What if I group these? What if I set one grouping at 3x cubed minus x squared plus second group 9x minus 3? 3 and 9. X cubed, x squared. Let's factor out an x squared out of this first group. And when I do, I'm going to have No, let's just do x. I got to do x. I don't have an x over here with this 3. You can't do x squared. When I factor out an x, I got 3x squared. No, I can do an x squared. Excuse me, I can factor out an x squared out of that thing. That would leave me with 3x minus 1. Okay. And out of this second group, what if I just factor out a 3, which would leave me with 3x minus 1. And now I got a common factor of 3x minus 1 along with x squared plus 3. So I've got x squared plus 3 as a factor. And then I've got 3x minus 1 as a factor. All right, well, let's set them both equal to 0. So let's see, I got x squared plus 3 equals 0. Subtract 3 from both sides. I got x squared equals negative 3. So look at imaginary to me. Square root of x squared equals this plus or minus. Let me get room for that plus or minus. Plus or minus the square root of negative 3. And what is the square root of negative 3 going to be? It's going to be plus or minus I times the square root of 3, right? Because the square root of negative 3 is the same as the square root of negative 1 times the square root of negative 3, and the square root of negative 1 is I, an imaginary number. All right, well, there's 2 of them. Let's get the third one. So I got 3x minus 1 equals 0. Add 1 to both sides. I got 3x equals 1. Divide by 3, and x is equal to 1/3. So what are my roots? My roots are 1/3. I got, that should be, I've got a positive I square root of 3, and I got a negative I square root of 3. 3 roots, exponent to the 3rd power, real or imaginary? Well, I got 1 real, and I got 2 imaginary. Whew. Shazam! How about that?